Oh, sorry. Okay. So just a quick recall: polymer, monomers, repeating unit. Those are keywords or key definitions, if you like, that you need to be able to define. Then addition polymerization, okay, breaking of bonds. The empirical formula of the monomer is the same thing as that of the polymer. And of course, in addition polymerization, only one product is formed. Okay, only one word, one large product. One large product results from what? Results from the reaction. So tiny stuff come together, two or more things will come together, as many as they could be, to form your large what chain, a long chain. Okay, that long chain is called a what? A polymer. That's your polymer. Okay, while this is your what? Your monomer. And we also said that your monomer, okay, usually they are unsaturated for addition polymerization. Unsaturated, while your polymer will be what? Saturated, or at least the degree of saturation will increase. The degree of saturation will increase. I said that because if you start with, say, a triple bond, you might end up with a double bond. If you start with a double bond, then you might end up with the what? A single what? A single bond. Okay? So now we want to focus on condensation polymerization. Condensation polymerization. So we'll look at the nature and the character of what? Condensation polymerization. Okay, condensation polymerization. So for condensation polymerization, just to bring the two together, comparing it with addition polymerization. In condensation polymerization, when your monomers, okay, usually you have different monomers. You have different what? Monomers. Different monomers means that they have different functional group. Different functional groups. Different functional groups. Okay? So you have your monomers, different functional group coming together to form a polymer, which is the large what? The large molecule that results from the reaction. The large molecule that results from the reaction, plus a very small molecule. A small molecule. And this molecule is usually, let's say, water. Water. Okay, or HCl if you like, in some occasions. So this reaction takes its name from the fact that small molecule water is usually lost. And that's why it takes its name, the initial name, from called condensation. Condensation, you know, condensation has to do with your vapor turning to water. Okay, that's just the origin of the name, condensation or polymerization, because this small molecule is usually lost. But our focus is this large what? The large molecule there, which is the what? The polymer. Large molecule, which is the polymer. And of course, you have two different what? Monomers coming together. Two different monomers coming together. Unlike your addition polymerization, okay, in which the monomer is usually what? The same. A thing can polymerize with itself and goes on and on and on and on like that. Okay, but for your condensation polymerization, you need two different molecules, okay, coming together. And that's easy to understand. Let me use this analogy. If want to form a big circle, let's assume that I have children, okay, maybe on the field, and children on the field, okay, and I want them to form a big circle. Let's assume I have children like this on the field, I will need each of the students to have two ends. Each of them to have two ends. Otherwise, if I have a student with one hand, he can't form a circle with the other one, because in forming a circle, what do? We join ends together, right?
Yes.
Okay. So if you want this chain to continue to form a large, each of these, this is a monomer. When it comes to polymerization, this will be a monomer. Okay, this will be another word, another monomer. They are different because this person A is different from person B. So if I want the chain to continue, then I will have to get another person, okay, with also stretching out the two ends. Okay, I'll take one more of this person to come here, stretch out the two ends. So if I keep getting them like that, the chain will keep what? Increasing until we have been able to form a very long what? A long chain. Okay, until I've been able to form a long chain that will now be called a what? A polymer. But the polymer consists of what? The monomers joined together. That's how we say a polymer is a large molecule formed by small molecules, many small molecules, covalently what? Bonded. Sometimes we call polymer macromolecules. Macro, okay? Very large molecules. So each of these units is the monomer. But for condensation polymerization, you can see I use different color. Each of the monomer is different. So usually we have A and B. So A will repeat itself, A, then B. Then I have another A, another B. They continue like that until I have a very long chain. So in doing this kind of polymerization, let's now use example of like a real molecule. Okay, let's choose a real molecule and see how it applies. Okay, let's choose a real molecule. So let's look at an example of monomer. Example of monomer. What could be a monomer for this polymerization reaction? Okay, we could have a reaction between, let's see, let me represent a molecule like this. This is 6 carbon, right?
Yep.
If I have this is OH, right? What functional group do you think this is? What functional group is this?
That's a carboxylic acid.
Brilliant. That's a carboxylic acid. On this other side too, it's a carboxylic acid. So this particular compound, yes. Okay, so let's assume that I have hydrogen here left and right. This will be an hexane 1,6-dioic. Hexane 1,6-dioic. Okay, 1,6-dioic. So now each of these represent the hand that I was showing the other time. One hand here and one what? One hand here. Can you see that?
Yes.
Good. So if I want this molecule to combine with another molecule, I could have something like, say, let's just say this. Now, okay, OH. Let me just say 4 OH here. So this will be a butanol, right?
Yes.
Yeah, but this is, I have 2 OH group, because don't forget we need 2 hands, because the formation here is not breaking a bond, it's at the edge where they keep attaching to one another. So this is like a yes, butan what? 1,4-diol. Can you see that? Diol. Okay, that's an example of a monomer. Substance that could be a what? That could be a monomer. Okay, so we could also have another monomer. Okay, let me do another 6 carbon. Then I could have Okay, let's have amine group, amine, 6 carbon amine. So I have NH2. Okay, so this substance that could form, that could be a what? A monomer. So here I have what? NH2. So this will be what? So you can name that. That is diamine. That's a diamine what? Amine group. Diamine group. Okay, this is called an amine group. Amine groups usually represented by NH2. It's called amine. Yes. Amine group. So now for your IGCSE work, it is very important that in the concept of the exam, they want to reduce how the complexity of this condensation polymerization. So what they do in your exam or your text is they reduce this carbon at the middle and represent it with a shape. It could be, for example, a rectangle representing that. So it will have COOH. Okay, can you see that? It simplifies it because the focus, what we need there is just what is at the edge. What is at the edge? Okay, so then this particular one too, they could just represent it by saying maybe a circle. You have something like this, OH. Then on this side you have what? OH. Can you see that?
Yes.
Then this other one too, can just use any shape, okay, to represent this. You have your NH2, so they can draw it out like that, NH2, or you just have H2. Can you see? Either way. So these monomers are the ones that we are going to be combining in different form to show examples of condensation polymerization. So in your textbook, if you are seeing these shapes, so you know the foundation of the shapes, where they got it from. The essence is just to simplify, because the focus of your syllabus is to see whether you can describe the link between the two, how they join hands together, not just essentially what's in between. Do you get that?
Yes, sir.
So based on this, we'll look at two types of polymerization, condensation polymerization here. We'll look at formation of polyester and formation of what? Polyamide. Okay? Formation of polyester and formation of what? Polyamide. So specifically for your curriculum, okay, for your curriculums, we'll just focus on what is required. Example of what? Condensation polymerization. So we are going to be focusing on formation of polyester, okay? Polyesters are a type of condensation what? A type of condensation polymerization. Example is what we call a tyroline. Okay, it's a specific example of what? Of a polyester. So your syllabus wants you to know that polyester. Then we also consider formation of polyamide. Polyamide, e.g., is your nylon. Okay, nylon polyamide. So we'll look at the formation of polyamide. Okay, other example of polyamide. Okay, it's your what do you call it? Proteins. Okay, but that should be under natural polymers, carbohydrates, protein, and fat and oil. Okay, so we should be able to get to that point too. So now, before we can fully understand the nitty-gritty of these two types of condensation polymerization, let's do a quick recall on ester, because it's very key, very important to this. A quick recall on what? On ester. Okay, now ester is formed through esterification. You remember that?
Right.
Okay, so what are the two? Give me an example of two molecules that could be esterified. Two molecules that could be esterified, that could undergo esterification. Or two homologous family.
Yes. Carboxylic acids.
Carboxylic acid, okay.
And alcohols.
And alcohols. Brilliant. So it is formed between the two functional groups, carboxylic acid and what? An alcohol group, okay? So give me an example of a carboxylic acid. Example of a carboxylic acid. A carboxylic acid. Just name it after your prefix. Remember your prefix, your meth, followed by what? Eth, followed by what? Prop, followed by what? Your boats, followed by what? Your pent. So your carboxylic acid are anoic. So you have metanoic, 1 carbon. Eth, 2 carbon, metanoic. Prop, 3 carbon atoms. So you have propanoic, and it continues like that. So which example do you want to give?
Pentanoic.
Did you say pentanoic? Or
yes.
Okay, pentanoic. So pentanoic will have how many carbon?
5.
5. So anoic here. So we are going to have that. Okay, so basically it's that simple. So that's CH3, CH2, 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 COOH. You understand this shorthand, right? Way of writing that.
Yes.
Okay, it's just a transcription from this to that. Okay, so give me an alcohol. An alcohol. Any alcohol?
Ethanol.
Ethanol. Ethanol will have 2 carbon atoms. Okay, OH. So I'll have this like this. Okay, and of course that is CH3, CH2, OH, right? Now, when the two of them react together to form condensation polymerization, to react together to form ester link. Ester link. Okay, what happens is that your carboxylic acid, okay, loses its OH group, while your alcohol loses its what? H. So the two combine together to form what? Water. That's where the small molecule is lost. Can you see that? These two come together to form water. Okay, so the other molecule will combine with one another. So basically, all you need to do is to draw what you have there. So let me just, because of space, I'm going to show it like this. CH3, okay, CH2. Can you see my CH? How many CH2 do I have? 1, 2, 3. So I can put it in bracket like this, meaning 3. Then I have my C, which is this one. O, okay, the other OH has been lost. So this link is going to join to what? To this alcohol, the remaining here. So I take that again. You just draw everything you have here. I have my CH3 and my CH2, CO. because OH has been lost. So that means my alcohol, the remaining part of my alcohol will join to this. So let me join that now. So I'm going to be having my O, okay, with my what? CH and my CH3. Can you see that?
Yes.
So that is formation. This is called an ester. This is an ester. So how do you name this ester? You name the alcohol part first. You name the alcohol part first. Then you name the words, followed by the carboxylic acid part. So I'm naming this one first, then this one follows second. Okay, so the name of this will be what? How many carbons do I have? 2. So it's going to be ethyl, 2 carbon, ethyl. Then I'm going to name this. How many carbon do I have? 5 carbon, ethyl pentanoate. So this is called an ester. That's a particular homologous family on its own. That's an ester. So where is the connection between the two of them? This is where they are connected together. So this is called the ester link. This is the link called what? The ester link. So that link is called the what? The ester link. Okay? So in case we now want to do polymerization, no, when I say poly, it means many. So if I have many of this carboxylic acid, like 1,000 of it, plus 1,000 ethanol coming together, I'm going to have a large molecule that will consist as many ester linkage as possible. So because that molecule will form several ester linkages, I would therefore call it a polyester, no longer an ester. It will be a polyester because in that molecule, I have many ester link there. It's just like my analogy. If you ask students to join their hands together, okay, if they are just 2 students joining their hands together, I will have only Only one joint. But if I have, for example, if I have 4 students joining their hands together, how many links will I have?
4.
If I have 4 students joining hands together,
4 students, 3.
yes. How many links will I have? 1,
3.
2, 3. Yes, 3 links. Do you understand that concept? So if I have 5 students joining hands together, I'll end up having 4 linkage. So the same thing. So when they join their hands together, they can form a big circle. Okay, a big circle. So that will be that circle will now represent a word, a polymer. Okay, the circle will represent a polymer. So just like me having like this, you know, they keep joining their hands together like that. Then I have, you know, them joining hands together that way. So I end up having a what? A polymer at the end of the day. So there must be a link between the polymer. That link is what we call either ester link or what? Polyamide link or amide link. Okay, so this could be an ester link. So for it to be an ester link, then it must be a bond between carboxylic acid and alcohol. Do you understand? My monomer, one will be carboxylic acid, the other will be alcohol. For me to have my what? My ester link. Or one could be an acyl chloride, and the other one will be a what? An alcohol. Acyl chloride or an alcohol. So I'll use the 2 examples because sometimes they could be very trickish in the exam where they'll bring in something similar. They just want to see if you have an idea of how the link can be formed. So now, having cited this example of ester, let me now show the formation of a polyester. A polyester. Okay, so let's see a polyester. So let's say formation of polyester. Okay, Terraline, just an example, but just focus on the polyester. So remember, we need monomers, right? Monomers. And the monomers will be different unlike in addition where the same monomer is what you have. Okay, so I mean usually the same monomer. So in this case now we have different monomers. So let's pick our monomers. Monomers here we are picking. Let me just use shapes now. Okay, shape. I have a carboxylic acid, COOOH. Okay, on both ends it should be a dioic, because if I don't have two hands, I can't be part of people who are forming the circle. That's why it has to be a dioic. Okay, plus let me use a triangle. Okay, my OH, which is what? My diol. So you can see diol and a what? A dioic. Okay, so now let's link these two guys together. So in this case now, let's link them together. We have linked them together before to show ester. So let's assume we have many of these, many, n of these and what? N of these, that's many, for them to come together. So how do we show the formation of polymer? We want to show a polymer being formed. Now they have undergone reaction. It's very simple. Just draw it exactly what they gave you, what you have there, draw it. So focus first on where they are going to join together, because that's the main thing, how they are going to be connected together. So let's do it. Let's focus on that. So I have this. Okay. Don't forget that your carboxylic acid loses what? OH, right?
Yeah,
While your alcohol will lose what? Your H. So the two of them is gone. Okay. The two. Okay. The two is gone out of that to form what? Water. So I'm left with what? So from here, next is to have my what? O. Can you see that? I have my O. Okay. So goes to what? My triangle. Okay. Just this shape. Then it goes to my what? To my OH, right? Good. Then on this other side, this side here, I have my what? Carbon, O, and what? OH, right? But if I do it this way, it means that I only form one what? One ester link. How can I show that it's a large molecule?
You put two dashes on either side.
Yes, I put bracket. Brilliant. So it means that I'm not going to terminate it like this. I'm not going to terminate it like this. So how do I know what's going to, if I put a bracket there, okay, if I put a bracket like this, yes, I know there's going to be a bracket, but how do I know what is going to be inside the bracket and out of the bracket? Am I going to cut it like this, or am I going to cut it like this? How do I know? Okay, so
are you asking me, or are you like suggesting?
yes, I'm just kind of suggesting. Okay, so how do we know that?
Okay.
You go back to the reaction. Okay, so go back to the reaction. Here at this edge here, what is going to be lost? OH, right?
Yes.
So therefore, it means that I'm going to draw this out. OH is cut off. So it means the OH should be outside. Okay, it means that this particular edge shows that it's connected to something else. You know, like when you are speaking English or something and you do dot, 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 it means that the speech continues, but you're not just showing the remaining part. It means it's a continuous, a sentence that sticks somehow continues. Okay, so you goes out here. Now on this other side, what will be lost here? What will be lost?
H.
H, brilliant. So it means that I have a link like this. So I cut off that H. Then I have my N, showing that this N shows that this particular link, everything here repeats itself on and on to form a large what? Molecule. So this is called the repeating what? The repeating what? Unit. One of it like this without the N. Okay, if this N is 1, then this is the repeating what? Unit. So, but if this N is a particular number, like say 1,000, 1 million, Okay, it means that this thing repeats itself a million times. Then this represents a what? A polymer. Okay, so this whole structure is a what? Represent a polymer. So you can see that a polymer consists of what? A repeating what? A repeating unit. So that is how we show the formation of what? Of polymer. So this is a poly what? A polyester. How do we call it a polyester? Because you have the ester link. Where is the ester link? This is the ester link. Okay, this is the ester what? We call it ester linkage. Okay, that's the ester linkage. And because many of it will be present there, as suggested by this N, then this molecule is a what? Polyester. Belongs to that family, polyester. So the actual name of this polyester will depend on what this rectangle or this triangle represent. Okay, it depends on what they represent. But in the exam at this level, they won't ask you to name the polymer. Okay, so the focus is just drawing the link and giving you a polymer. They can ask you to draw the monomer, or they can give you two monomers. They can ask you to draw a what? A polymer for it. Do you get that?
Yes.
Okay. So this formation of a poly what? A poly ester. Okay. So because ester is usually formed between what? Carboxylic acid and what? And alcohol. So this will just be a perfect example of a polyester. Okay. Yeah. So let's look at formation of a polyamide. Polyamide. Formation of polyamide. That's the next thing we want to consider. Formation of polyamide. Formation of polyamide. Okay. So the same thing goes just like ester. You need to understand, okay, what's an amide? What's an amide? An amide functional group. An amide functional group is something like this. This is an amide. This is a homologous family called amide. Amide exists when you have carbon, CO, and NH2. That's your amide. That's your amide. Okay, your amine is this amine. Why this is what? Amide. Okay, so if it is your RCOOH, it's called carboxylic acid. But remember, this OH is taken and is replaced by NH2, then it is called what? Amide. Amide. If you have RO and it is Cl, it is called acyl what? Chloride. Acyl chloride. Acyl chloride. Okay, because you can see your chlorine replace your OH. That is called your acyl chloride. It's also another functional homologous family that we are not looking in details at the GCSE level. Okay, so if your NH2 replace your OH, then it is called what? Amide. So, but if you have your OH there with this carbonyl group, this is what we call a carbonyl group. Carbon double bond. Okay, oxygen. It's called a carbonyl group. Okay, so I have a carbonyl group and NH2 is amide. A carbonyl group and OH is carboxylic acid. Okay, a carbonyl group and chlorine is called acyl what? Chloride. Acyl chloride. Okay. You got that right?
Yeah, I did.
Okay, so let me just take that away. Maybe we need it. Let me leave it on that side. So this is your, of course, you know your carboxylic. carboxylic acid. Okay, so let's do this. Let's choose our monomers. Let's choose our monomers. Okay, let's just take this again. So we're doing this. Okay, let's say an acyl. Okay, acyl chloride. Choose an acyl chloride plus let's say an amine group. So let me use a circle now. NH2, okay, NH2. So the two of them want to join together. This is where they are going to join together. Just these two. These two groups will join together. So to really show it intentionally, I want to show the hydrogen, you know, one H and the other what? H. Okay. So when the link comes together, it is just these two guys that will link together. The two guys will link together. It's going to form HCl. But if this were COOH, if it was OH, then it's going to form water. That's why we said initially, condensation polymerization can form HCl or what? Or water as the small molecule that will be formed on the side. Small molecule that will be formed on the side. I hope you got this.
Yes.
Okay, so this could be acyl, it could be acyl or what? Or carboxylic what? Acid. So either of these two can react with your what? With your amine. Can react with your amine, then it's going to form your what? Amide link. See, when these guys combine together, either of these guys combine together, it's going to form your what? Your amide link. So let's show how the amide link will be formed here. Like I said earlier, just draw exactly what you have. First, focus first on the link part. So I have my carbon, my double bond O. So my Cl is gone. Cl is gone. So my link is joined to what? Hydrogen is gone. I am left with what? Nitrogen. So can you see the nitrogen? And on this nitrogen, what do I have? I have hydrogen. So I put it down. Just putting it down, just make it look neat. You could put it up like this. It doesn't matter. But if I put it down, just make it look artistic somehow. Okay. And because also at the higher level, what we will call steric hindrance orientation, because these molecules are actually they are three-dimensional molecules. So just want to show that element. But at this level, you put it up, you are still pretty fine. Okay. So the next thing is my word O. Okay, that's my shape. Then my word N here, H. Okay, and my word H, right? But we know that to show that it is a polymer, usually we have our brackets, isn't it? So what do we show? Is this hydrogen going to be inside the bracket or outside the bracket? How do we know? So I want you to respond to that now. How do we know what's going to happen to the hydrogen? Will it be inside the bracket or outside?
It's going to be outside to indicate that it's going to be taken off from the next bond.
Okay, so it's going to help in forming bond with the next one, right? Good. Yes. So what about on this side? I have this, right? Okay, so my bond, will it be like this?
Yes, to be like that.
Yeah, this Cl goes out to form with something else. So now if I put my N here, okay, I have my words, my polymer, because this N tells me that this thing that is in the square bracket repeats itself. So this is my word, this O molecule with the N is my polymer, but my repeating unit is just this, everything inside without a bracket. That's my repeating word unit, the unit that repeats itself. Okay, or if the N is 1, this is my repeating unit. Okay, but when I put N like this, it becomes a polymer because that N denotes that it keeps repeating itself. Okay, so this is a word, a amide. So the question is, where is the amide link? This is the amide link. Okay, this is the amide what? Link. So if I see this link in a molecule, I know it's my what? Amide what? Link. So I'm going to, in my polymer, I'm going to be having many of these. So it's called a poly what? Amide. A poly what? Amide. An example of that is your nylon. Okay, is your nylon. So don't forget that HCl will be lost in this particular example that I use because I use acide. If I'd use this COOH and this OOH plus amine NH2, okay, O NH2, okay, I would have formed a what? A polymer, a polyamide plus what? Plus water. Can you see that? Because
No,
this is, you saw what?
plus what?
Plus water.
Okay.
Yes, because this is OH. OH and hydrogen would have formed what? Would have formed water there. Okay. So that's the concept. It's pretty interesting and simple. Okay. Pretty interesting and simple. So yeah. So we'll discuss uses of this polymer. Okay, uses of this polymer. I'll touch about their plastics and pollution. Then I'll talk about natural macromolecules. Just those are just very simple stuff. Natural macromolecules. They will now solve past questions. Okay, is that good?
Yes.
Okay, so now let's just touch quickly uses of this uses of polymer. Okay, I know those ones are like white arts things that you could easily read off, but let's just brush over uses of polymer. Okay, any use that you want to recall. Okay, we have a nylon and terraline.
Yes.
Are used for what?
It can be used for in the textile industry.
Textile, yes. It used to make clothes. Yes, in textile world, textile industry for making clothes. Okay, yeah. What about nylon? Nylon is used for making ropes.
Yes.
Yeah, it's used for making ropes. Okay. Yeah. Any other? Yeah. Have you heard about the word PVC before?
Yes, it's that plastic thing.
Yeah, polyvinyl chloride. Okay.
Yes.
Polyvinyl chloride is used for electrical insulation. Electrical what? Insulation. Now, most of your wires, okay, in the house, okay, they have this insulating substance around them. Okay, that's called. If you look at those wires, you will see written on it PVC. Okay, PVC. Okay, then of course you can use it for making pipes. Those water pipes or soak away for gutter and all that. They're made up of PVC. Okay, then of course the common one, your polyethylene. Polyethylene usually used for making these plastic bags. Okay, plastic bags used for electrical insulation too, for making bowls, plastic cups, etc. Okay, slippers
Yes.
and slippers and so on and so forth. Okay, so basically that's the use of polymer. Okay, now you should be able to connect plastic to pollution. Plastics and what? And pollution is very important. Okay, so you could have one or two questions underneath that related to plastic and pollution, which you should be able to answer to get your 1 or 2 marks there. Okay, so the bottom line is the bottom of the problem with plastic, okay, is the fact that they are what? They are
Biodegradable.
Non-biodegradable. Okay, non-biodegradable. So that simply means that microorganisms can act on them to destroy them. Okay, and I told you earlier that plastics are mainly what? Alkanes. You remember?
Yes.
Plastic are alkanes. Okay, and alkanes are what? They are all what? Unreactive. So that makes it difficult. That's why your plastics will not decay, because alkanes themselves are unreactive. Alkanes undergo two basic reactions that we consider earlier, two basic reactions. Alkanes undergo substitution reaction. Okay, they don't undergo addition, substitution, free radical substitution reaction in the presence of UV light. Okay, and what? Combustion.
Yes.
Combustion. That's why mainly what some people do is to just burn plastics, burn nylons around them to combust it, burn it. Okay, good. So they because of this, plastics are major, source of visual pollution. Okay, and of course they fill up available waste. So you have waste, a whole lot of plastics around, nylon, papers, everything around. Okay, so we have two options to burn them, but of course we know burning them is not satisfactory solution to their disposal. Okay, since when you burn them, they produce what? The burning of this plastic produce what? What's the implication of
gas?
Carbon monoxide, carbon what? Carbon dioxide. Carbon monoxide is a poisonous gas that can come out of that. Okay, why carbon dioxide is a greenhouse what?
Greenhouse gas.
The greenhouse gas. So you can see plastic. So burning it is not an option. It may look like just a temporary solution, but as you are burning the waste away, the only thing burning does is that it reduces the visual pollution. Okay, if it is properly done in an incinerator, or it's done in a dump site, a properly structured dump site. Okay, but even at that, while you are burning, if you've seen a dump site being burnt before, you'll see a lot of carbon smoke that is released into the atmosphere. The whole street becomes blackened. In fact, it's a whole lot of issue, plastics. Okay, so everyone needs to, that's why I tell students, you can also be thinking, what can we do? Issue of plastic has been a problem since time immemorial. And it looks as if we don't have a solution yet. And we have people who keep studying, because they are called material scientists. They keep studying what can be done to ease the problem of pollution. So you talk about green chemistry. Okay, can we use less of plastic? Can we consume less of crude oil and all that? So people are looking for alternatives to using plastics. Okay, wrapping your food with paper bags. Okay, rather than using plastic, wrapping it with leaf extracts or part of plant wood and other. Instead of making chairs from plastic, can we make chairs from wood? Okay, can we make bowls from wood? So those ones, wood is biodegradable, can be eaten up by ants, but not plastic. Okay, so the best term solution for the disposal of plastic seems to be recycling of what? Polymer waste. Okay, so the best solution is what? Recycling. That means that we keep reusing it over and over and over and over. Okay, so recycling is the best option for the environment. Okay, so even though recycling may come at a cost, but it's better off in the long run, because you're not going to consume new crude oil. You're already using the one that is available. And we have a whole lot of that, especially in our Lagos now, improvements going on. People picking, if you go to parties, before you know, some guys come around and pick your, bottled water that you throw on the floor and so many other things. Yeah, and now in most of our streets, we have two, people are getting wiser in terms of waste disposal. You have two containers, one for plastic, one for for metals and all that. So people are now getting sensitized. So sensitization is also a way to go. Sensitization, okay, and policy making by government. Okay, policy making by government. So these are ways to tackle pollution issues. Okay, good. Now the gases that come out of this particular what do you call it, disposal. Don't say the gases are harmful. Your syllabus does not actually want that word harmful. Don't describe carbon monoxide as harmful. Describe carbon monoxide as toxic or poisonous. If you do harmful, you will lose your mark. Carbon is toxic or what?
Poisonous.
Poisonous, not harmful. Okay, because that word harmful does not actually, cover up what carbon dioxide does. Harmful, when you say harmful, in what sense? Okay, something can be harmful. Can it cause a cut? Okay, or so it's actually what toxic. Okay, it's toxic. Good. Okay, so when your plastic is burnt, plastic when it is burnt does not produce sulfur dioxide. Please don't include that. So student will link it to sulfur dioxide and acid rain. No, at best it is carbon dioxide and acid rain, because carbon dioxide dissolves in water to form carbonic acid. It's an acid anhydride, not sulfur dioxide. Do you understand? So those misconceptions should not come up in case you are answering question on polymer and they link it to pollution. So I'm just trying to tackle those misconceptions that you may have there. Okay, so not sulfur dioxide. The only time sulfur dioxide can come in is if you are talking about directly burning petroleum products, or petroleum. Okay, you are burning petroleum and that petrol contains sulfur impurity. Then sulfur dioxide can come out of there. Okay, so plastic do not contain sulfur. Good. Another misconception is to say that is to refer to the emission of carbon monoxide would be a particular, a particular problem. Okay, so the problem of carbon monoxide here is as a result of what? Incomplete combustion. If you completely combust your carbon, your plastic, then you still form carbon monoxide. So carbon monoxide is basically a problem of incomplete combustion of carbon containing substances, okay, like coal, natural gas, liquid fuels, wood, and plastics. So any carbon containing substance, if it undergoes incomplete combustion, it will form carbon monoxide. Okay? Do you understand that? Okay. So those are the things you need to watch out for. Okay. So let's talk about natural what? Natural polymer. Natural polymers. Okay. So for your natural polymers, basically your syllabus would like you to just refer to, so let's just call it natural macromolecules. Natural macromolecules. Can you give me an example of these natural macromolecules?
Examples of?
Natural macromolecules. Examples. Natural macromolecules. Whoa. Okay, what are the three main constituents of food? The three main constituents of food, the three main nutrients that we have.
So can you hear me?
No, what are the three main nutrients that we have?
Sorry, it was like I disconnected for a second.
Okay, sorry.
I was saying carbohydrates, proteins.
Okay, so we have your carbohydrates.
Yes.
Okay, carbohydrates, proteins, and what?
Well, those are the ones I know. I don't do biology, so I wouldn't know the cheaper.
Okay, carbohydrate, proteins, and fats. Okay, fats. Those are the three main. So when we talk about natural macromolecules, we want to focus on these ones. Okay, rubber too is a natural polymer. Rubber is a natural polymer. So basically here we want to describe each of these, just a little, each of these particular polymer. Your carbohydrate is a polymer of simple sugar. Carbohydrate is polymer of what? Of simple
sugar.
Simple sugar. Your simple sugar example is your glucose. Your glucose, okay, is your simple sugar. Okay, so your carbohydrate is a polymer of simple sugar. Okay, the same thing, your protein. Your protein is a polymer of what? Amino what? Acid. Okay, polymer of what? Amino acid. So not too much details of the biology side, but basically this is chemistry really. Okay, nutrient is mainly chemistry. Okay, so polymer of what? Of amino acid. And basically a protein is a polyamide. It's a good example of a poly what? A polyamide. Okay, your carbohydrates may be more of a polyester. Okay, polyester, yeah. So your fat and oil too. Okay, fat and oil, they are esters. Okay. Okay, fat and oil are what? They are esters. Okay, esters, just similar to your tyrosine. Okay, similar to your what? To your tyrosine. Okay, so we want to focus on this. So for your syllabus, you need to now know. Let's take protein first. Proteins. Was said earlier that your amino acid undergoes condensation polymerization to form what? Amino acids. Many of them, they undergo condensation polymerization to form what? To form proteins. Okay, proteins and what? Proteins and water. Okay, proteins and water. That's the reaction is condensation what? Condensation polymerization. Okay, so now if we now do proteins, we can add water to protein. Okay, water to protein in the presence of an acid. Okay, and boil it. It is called hydrolysis. It is called what? Hydrolysis. That means we are going to heat it or boil it with what? With acid. So a proton, this is an acid. Okay, just represent acid, maybe HCl or something. It's called hydrolysis. Hydrolysis means what? To split. Okay, amino acid. Can you see that? A large molecule, we are splitting it. We have looked at protein. Now you know what a polyamide is, right? So if you now want to break your polymer, this is your polymer now. Okay, if you want to break it to your monomer, that process is called what? Hydrolysis. Okay, so you can break it down. So now let me give you an example of amino acid. Why they call a substance amino acid. Okay, but just I'll need you to like 10 seconds to digest this more. You can see amino acids come together to form proteins and water. So we can break that protein down to amino acid. The process is called hydrolysis. The word hydro means water, while lysis means to split, to break, to disintegrate, to set apart, to break apart. That is lysis or lysis, if you like. Do you understand? So hydrolysis, that's why we are adding water. The addition of water, okay, and acid, of course, brings about the splitting of that word, of that molecule. Okay. Okay, so let me show you something about amino acid. So every amino acid has an amino group and a carboxylic acid group. Okay, this is how we represent, amino acid in short form. This means the chain can continue here. Usually this upper one is H. Okay, so you can see that this represents what? An amino acid. Why do we call it amino acid? It's a molecule that has two functional groups, amino here and what? Carboxylic acid here. Can you see? Amino acid. What a wonderful way of combining the name. That's why each amino, we have about 20 amino acids. Okay, so each of these amino acid has two functional groups on a single molecule. So if I combine this with another amino acid, okay, H2, right? Another amino acid. Okay, I'm going to be having H2 and what? COOH, then R. Okay, you can see this OH will take combine with one H from here, and I'm going to be having what? An amide what? Amide link here. So if I have many amino acid combined together, it's going to result into a polymer called what? Called proteins. So if I break down my protein back, I'm going to be forming each of these what? Each of these amino acid. So coming to form protein is condensation polymerization. Going back to form your amino acid is called what? Hydrolysis. Can you see the same thing with your fat, the same thing with your what? Carbohydrate. So that's what your syllabus wants you to know under this natural polymer, just for you to be aware that the natural polymers consist of monomers. Carbohydrates consist of simple sugar. Your fat is a polymer of what? Of what do you call it? Polymers of esters. Okay, polyesters. Okay, or lipids, fat and oil. Then your protein is a polymer of amino acids. Okay, so let's look at maybe fat. Let's talk about fat now. Fat. Okay, let's talk about fat. So I told you both fats, that is animal fat or vegetable oils are all what? Esters. They are all esters. In fact, a typical example of a fat is what we call glycerin stearate. Okay, but you don't need to bother much about this name. Glycerin was stearate. So basically, you just need to know that your fat, you can break down your fat, okay? Your fat plus alkaline, sodium hydroxide. Now I want to look at hydrolysis of fat. Hydrolysis of what? Fat. Sodium hydroxide, okay? You can break down your fat into what we call glycerol, okay, and what? And fatty acid. Fatty acid. So your fat is a combination of fatty acid and what? Glycerol. Don't forget that your glycerol will have OH, or you can say O. While your fatty acid will have what? COO what? OOH combined to something else. So this is where you have your link. Can you see that? Can you see why your fat is a poly what? Is a polyester. So when your H from here and your OH from here is going to form your what? Ester. So fat is a poly what? Is a polyester. Okay, so to do hydrolysis, this is called alkaline hydrolysis. Alkaline what? Hydrolysis. Yes, alkaline hydrolysis. So that is called your glycerol and what? And your fatty acid. Okay, so basically that is what you are expected to know about your fat. Okay, you don't need to learn the structure or the full equation of hydrolysis of fat. Don't need the full equation. Okay, you just need to know the word equation. Fat plus sodium hydroxide will give you glycerol and fatty acid. And if you have something like, say, glycerin stearate, okay, I would draw the structure for you, but you don't need it. It's a bit complex, but so plus your sodium hydroxide, okay, plus sodium hydroxide is going to give you your sodium stearate. Okay, sodium stearate plus what? Plus glycerol. If you remember stearate, like saying alkanoates, butanoates, because an ester, that's how ester ends. Okay, sodium what? Sodium stearate. Okay, so this is your glycerin. Glycerin actually has 17 carbon. Maybe I should just draw one so that at least you'll be able to appreciate what this compound is. Okay, glycerin stearate is 17 carbon. is going to be H35. Then you have your COCH2. So it combines H. Okay. You have your OOC, the same thing, C17, H35. Okay, you have another C17, H35, COOCH2. Okay, so that is glycerol. Glycerol is usually 3 carbon, let's say plus sodium hydroxide. So it's going to break down. So I'm going to be having 3C17, H35, COO sodium plus my glycerol. Now this is where it's getting simpler. Glycerol is 3 carbon chain. Okay, 3 carbon is going to have 1 H, OH, and my CH2OH. So this is the alcohol. Can you see this alcohol that combined in the first place? This is called a glycerol. Okay, glycerol. It's just like saying 1, 2, 3, propane 1, 2, 3, triol. That's your glycerol. 1, 2, 3, triol. That's your glycerol. So glycerol is just like the old name for it. Then you have your sodium stearate. Sodium stearate. This sodium stearate is formed. If you remember, let's say carboxylic acid plus what? Plus sodium or alcohol, sodium hydroxide. Can you remember this reaction? Reaction to carboxylic acid. What's going to form? CH3, COO sodium, right? Plus what? Plus water. This is called sodium ethanoate. Can you remember reactions of carboxylic acid?
Yes.
Yeah. So this is sodium ethanoate. So this is just on a large scale. So, but because I have this carboxylic acid, 1 here, 2 here, 3, join, it's a trioic. So I'm going to be having sodium stearate. Can you see that? So then I have my word glycerol. Okay. So this is the hydrolysis of what? Hydrolysis of fat. Hydrolysis of fat. So you just need to know the hydrolysis of fat, hydrolysis of carbohydrate, hydrolysis of protein, and hydrolysis of what? Of your complex sugar. Okay. So the last one will be carbohydrate. Carbohydrate, and that is pretty simple. For carbohydrates, you should know that your glucose, okay, come together to form what? To form starch and what? And water. That is small molecule that is lost. Okay, the structure of glucose is so large. You want to draw it, but your glucose is C6H12O what? O6. That's your glucose. So if I have many of these joining together, many, I'm going to form a large what? A large molecule. So if this represents my glucose, let's say this represents my glucose, OH and what? And OH. At the end of the day, I'm going to be forming my starch, okay, like this. Can you see that? It's a long molecule. So I'm going to be having O, okay. I'm going to be having O like this. So this will be my what? My starch. This represents my starch, okay. So that's condensation polymerization. So on the other hand too, I can hydrolyze my starch. Okay, split it into what? Into glucose. Okay, I can break it down into what? Into glucose. So with the elimination of what? Of water. So that is called what? Acid. It basically is going to need boiling. I will heat it. Okay, and of course I will need acid. So it is called what? Acid what? Acid hydrolysis. It is called acid what? Hydrolysis. Okay, which is pretty very simple. Okay, so that is basically all you need to know about your what? Your polymer. Okay, so that's all. We covered everything on condensation what? Polymerization. Okay, so the next thing to do will now be to solve what? To solve questions. Okay, so let's look at this question. Is that big enough?
Yes.
Okay. So let's try out this question and see. Yeah, for your of course your organic question will start from question 30, 30 35 upwards, or 20, 36 sometimes upward. Okay, so let's see how this goes.
So there are not many.
For your multiple choice, organic question is just in any year, maybe five questions. Okay, then okay, so let me see what you can do with this question.
A.
A solution W in water has a pH of greater than A. Why did you choose A?
Because that's a carboxylic acid, and acids have pH of less than 7.
Okay, so brilliant. That's the answer. So next question. Yes. Which one are you choosing?
Deciding.
What?
Sorry, a saturated compound polyethylene.
So which option?
B.
A.
B.
Did it B or D?
B.
Okay. So B is correct. B is correct. It's a polyethylene. Saturated means single bond. So that's saturated compound. Single bond. Saturated compound is single bond. Now here is a polyethylene, not a polyethane, not ethane. Okay, it is what? Ethane.
Yes.
Telling us that it was ethane that combined together to form the polymer. Okay, brilliant. So number 3.
Can I see D?
D.
No, I can't see D.
Okay, you can't see D.
Yes.
How about now?
Yeah. Yes, it's D.
D. Okay, formation of polymer. Yes, alkanes don't form polymer. Alkanes don't form polymer. So ethane can form polymer, yes. But let's get this. If we form the polymer, it won't be called polyethane. It is called poly what? Ethane. Yeah. Okay. So that's number 4 now. You can see it's very interesting. You meant to get a concept.
C.
C. Polymerization of ethane.
Yes.
Oh, sorry, no. I'm looking at question 5. Question 4. You're asking question 4. You said it's C or K. Brilliant. C. Yeah, this should be C and this should be D. So this is C, correct? Because your repeating unit is this, right? Good. So if you take your, how do you form your monomer from your repeating unit? How do you form your monomer from your repeating unit? Just add your what? Add your double bond to it. Okay? Then you get that. Correct. Fantastic. Okay? So number 4.
I'm on number 5.
Oh, number 5.
Okay.
So that was number 5.
Yeah, I said 5 is C.
5 is C. Okay. That's absolutely correct. Absolutely correct. 5 is C. Of course, you know, combustion of your methane, okay, plus oxygen, okay, possible could produce carbon dioxide and what? And water. You need to balance that equation. Of course, your fermentation of sugar, okay, the fermentation of sugars could be glucose, okay, when it ferments, could produce what?
Carbon dioxide.
Okay, you can produce carbon dioxide and what? Ethanol, right? Then, of course, this polymerization of ethene can only produce a polyethene, one large molecule. Remember, addition reaction, addition polymerization produces only one large molecule. Then, of course, your respiration is your glucose, okay, plus oxygen to produce what? Carbon dioxide plus maybe water vapor if you like, plus what? Energy, okay? That is your what? Your respiration, okay? Number 6, which is the last multiple choice that we're going to look at.
D.
So number 6 is what?
B.
E.
B. B.
B or D?
B.
Okay, ethene and polyethylene, correct. Ethene and what? Polyethylene, correct. So that's brilliant and fantastic. So let's look at a theory question. Yeah, let's look at a theory question. So how can you tackle that? So it says explain the difference between these two types of what? Between these two types of polymerization. So basically, we are talking about addition and what?
Condensation.
Yes, addition and condensation. So the difference.
In addition polymerization, an alkene, the double bond in an alkene is broken to form bonds with, what do I call them? To form bonds with other.
Addition polymerization. Addition polymerization, okay, involves the formation of saturated molecule, saturated polymer. Okay, saturated polymer, yes. In addition polymerization, only one large molecule is formed. But in condensation polymerization, a large molecule and a small molecule is what? Is formed. A large molecule and a small molecule is what? Is formed. Okay? In condensation polymerization, you need two different words, monomers. Two different monomers. But in addition polymerization, you could have just a single word, a single monomer. Okay, it can combine with itself. Okay, in condensation polymerization, you need more than one functional group. But in addition polymerization, you have just only one functional group, and your reaction will go on. Do you get it? Question 2. Some plastics formed by polymerization are non-biodegradable. Describe 2 pollution problems that are caused by non-biodegradable plastics. Plastics that are non-biodegradable, what pollution problem can they cause? Okay, yeah. So those are just a pollution problem. For example, if animals in water or even on land, ingestion of plastics, let's assume that a goat decides to eat plastic, that's trouble because it's not going to digest, right?
Yes.
Yes, ingestion of plastic can be fatal, okay, to animals. Okay, can be fatal to animals. Then, of course, combustion of plastics, okay, produce what? Toxins.
Toxic gases.
E.g., carbon monoxide. Okay, can produce toxins, carbon monoxide. Then, of course, plastic landfills where they keep plastics and all that. Landfill is using space, land that is meant for agricultural purposes. So when you have a landfill is very big, yes, land that is meant for agricultural purposes, recreational activities, you turn them to landfills. That means that landfill uses natural resources, land. Okay, so that's just when you are discussing issues that has to do with pollution, you have to be socio-economic and scientific in what in the expression. So you have to look out it's about environment and people, human and regional effects, or human and geographical impact of pollution. That's where your explanation will surround. Okay. So let's look at another question. Okay, now it says the polymer known as PVA, okay, used in paint and adhesive, the structure is this. Deduce the structural formula of its monomer. Deduce the structural formula of its monomer. Deduce the structural formula of its monomer.
Okay.
So you just need to be able to look at the molecule and see, okay, the first thing is there any form of repeating unit?
OC O CH3.
You can see here that.
Oh, wait, yeah. The CH2, CH, like between, yeah, there's, I don't know how to say it, but I can see it, yes.
Okay, so it looks as if we divide this into 2, right? It looks as if reaction took place between this and this, right?
Yes.
So therefore, we can see a repeating pattern, something like this, okay, and something like this. That's a repeating pattern. So we want to pick one of it, which is a CH2, okay, CH, right? And the words C and the O, CO, CH was 3. So basically it means that if this was an addition polymerization, then the double bond would have been here.
Yes.
So that this will break, because we have the 2 of them with another 1, 2 double bonds CH to form O, and COCH what 3. Then the reaction could take place between this and what and this. The bonds will break. Okay, so this is our what? Our monomer. This is your monomer. Okay, so that's how from your addition polymer. So all you need to do is to just try to see if you can find a repeating unit. When you find your repeating unit, bring back your what? Your double bond into the repeating unit. Okay, and you'll be fine. So now the condensation polymer can be made from the following. So they gave you two monomers now. Draw the structural formula of this polymer. So basically, if you remember what we look at, we said let's just still hold this on this side, right? See, we have the CH word 2, right? 4, C, double bond O. You know that your carboxylic acid will always lose the OH, right?
Yes.
By this group, okay, we lose one hydrogen. One hydrogen will go from here. So if one hydrogen goes there, I will left with N and what? An hydrogen. Then I continue my link, which will be what? CH2, 6, okay, N, can you see that? Okay, H, because I know that this guy will lose an H, so that H goes. Then on this side too, he's going to lose OH. This OH will be lost. Okay, so basically, I'm going to take away this OH. I'm going to take away that OH there. So I would like to take this too so that I can draw it well. So I'm going to be having my double bond O and what? OH lost. Can you see that? Okay. That's my polymer. That's my polymer. Just pretty simple. So you can see here they retain that we are representing with your what? With shapes. So basically the focus, when you can show the link, you can show your link, you're fine. Okay. So if they put shape there, you draw the shape. If they put carbon chain, you put the carbon chain.
Okay.
Okay. So describe two problems caused by disposal of synthetic polymers in land sites. Okay, it's like a repeating question. Okay, one problem caused by burning what? Synthetic what? Polymer. What's the problem for burning? Problem of burning synthetic polymer.
Toxins.
Yeah, it's toxin, carbon monoxide, which is the toxic gas can be produced. Okay, states two uses of synthetic polymers. Two uses of synthetic polymers. Yes, two uses of
types.
Okay. Yeah, in making what? Clothes, making of clothes, making of pipes, okay, bowls, okay, insulation, okay, insulators, etc. Okay, we say carbon monoxide is what? Is a toxic what? Toxic gas, not harmful, but toxic gas. Okay, yeah. Yes, of course, landfill, okay, visual problem. I mean, the site of landfill is something that is not good. Okay, then of course landfills waste what? Landfills waste land. Okay, that could have been used for other agricultural purposes, other useful purposes. Okay, yeah, you could call dangers to animals. Okay, dangers to animals. Okay, yeah, especially if animal ingest that. Okay, so draw the structural formula of the monomer of the polymer. So you can see another question here where they gave you a polymer and they're asking you to draw the monomer. Okay, so now this is polymer A. This is polymer A. This polymer A is your what? Addition polymer, right?
Yes.
Yeah, additional polymer. You'll be able to see that if you cannot see your ester link, you cannot see your carbon ester link or your amide link, then you know that it's your what? It's your what do you call it? It's your additional polymer. So if it's an additional polymer, it's easy. Identify the repeating unit. My repeating unit seems to be this, right? So if you understand sequence in maths, you know, okay, this is my repeating unit. So you have it on and on like that. So take your repeating unit, draw your repeating unit, okay? I have my H, 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 then I have my CH what? CH3. That's my repeating unit. Then put a double bond, you're fine. Okay? That's the monomer. Sometimes they can ask you to name it. They can say, what is the name of the monomer? To name the monomer, they can ask to name it. So let's try. Though they didn't ask us here, but let's try. What's the name of this compound? What's the name?
Ethan 1
CH2 CH3. That's the compound. No. This is what's the functional group? In.
sorry, ethene. It's ethene.
No. Hmm?
Sorry, what's the functional group?
Yes, that's a propane. How many carbon? 1, 2, 3. They just draw it that way. It could have been drawn like this. It's still the same thing. Okay?
Okay.
Like this. It's still the same thing.
Okay.
It's still the same thing. So you can see that.
Hello?
Okay. So identify the functional group in the circle for polymer B. What's the functional group?
So I was going to say oh yeah, carboxylic acid.
No, in the polymer. Not in the monomer, in the polymer. What is the name of the link?
This one is an ester link.
Brilliant. That's an ester link. So the functional group is ester. Do you understand? So if they had asked you, yes, if they had asked you this, okay, OH, and they're asking you like this, say, what is the function? They now circle this. What functional group is carboxylic acid? Can you see that?
Okay.
But this is in the polymer. You cannot have the acid in the polymer. Do you get that? That is why this molecule, that's why it is a polymer ester. You name it after its functional group, ester. So you have many ester. One is here, another one is here, another one is here. So it's a polymer ester.
Right.
Okay, you got that? Okay? Yes. So deduce the two types of organic compound which have reacted to form polymer B. So you can see the two types that reacted to form the polymer what? The polymer B. Organic compound. So what do you need to do? You need to identify your words, your repeating, you need to identify the repeating unit. Then in the repeating unit, find out the functional group that may have formed your link. So here, you know that this is an ester link, right?
Yes.
So To form an ester link, what was lost? OH was lost and what?
OH
Hydrogen. So you now return that OH back to where it was. That OH will go back to what? To this, right? OH, right?
Yes.
Why this hydrogen will go back to this? H. Can you see what I did?
Yes.
So on this side too, this guy will collect the OH, while this guy will collect it H. Can you see what I did? If I draw it this way, therefore, my two functional group will be what? Or, which is what? This. OH, OH, right? And what? This one, which will be my what? C, O. I return the OH back to it on one end. Then on this end, I have my double bond and I return the OH back to it. So I form my two molecules.
So alcohol and hydrochloric acid.
Yes. Did you see? So you have drawn it. Those are the two. Okay. So just draw it for them there. Okay. That's how you could have named this because you don't know what this square is. So you can't give it a specific name. Or if you like, a dioic and a what? A diol. A diol, a dicarboxylic acid, and a diol. You got that?
Yes.
Okay. So yeah, let's say this one more. Difference between addition and condensation polymerization. We look at it in the previous question. I helped you out. So, but now I want you to really state it yourself.
In addition polymerization, two different functional groups are needed. But in addition polymerization, one group can form a link with itself.
Okay. So basically, if you're answering this, make you look at the mark, it's 2 marks or 3 marks. So if you just tell them, the first thing you said is just, we'll get to your 2 marks, telling them that your addition polymerization, okay, only one word, only one product, right?
Yes.
One product is formed, but your condensation polymerization does what? Condensation produces what? Produces small what? Small molecules, e.g. what? Water, right? And a what? And a large molecule called the polymer. So you get your 2 marks for that, 1 mark for this and 1 mark for this. Then here they said 3 marks. Classify A and B as either addition or condensation. So the question is in 2 parts. First part and what? Second part. Okay. So the second part of the question, classify A and B as either condensation or what? Addition. So what is A? Is it addition or condensation?
A is condensation. No. Which one is A? Okay. A is addition.
Okay. A is addition. Okay. Why B is what?
Condensation.
Okay. So that's it. Okay. A, molecule A is addition polymer. Why B is what? Condensation or condensation polymer. Okay. Yeah. I think that's we've done